Okay, this will be over damped, critically damped. This is under damped. Kids entered my room. Huh? Okay, now we have this one. The value of B will determine the nature of oscillation, the nature of oscillation. Over damped, undamped, underdamped, critically damped. Sir, what is the meaning of this? Very difficult to manage kids. 5 years, 6 years, 7 years. Okay, now. These are the types of conditions will come. Now you have to ask question from where these equations you have brought it. I have plotted this particular thing. So it is the amplitude. The amplitude itself what will happen? So like from where this harmonic everything has come, this particular amplitude what will happen? The way the value of B what happen based on that what happen? The type of oscillations what we can get it. So O damped, critically damped, under damped, undamped. Undamped means when B is zero, when there's no any damping effects are there. Critically damped. So when this critically damped conditions will come, next question comes. So when the critically damped, if B is very high, or damped, okay, gradually this one means here the block is not permitted even to complete one oscillation. You can see that the amplitude what happened will start. So this is what I'll write A naught. Actually, I should this undamped is what an ideal condition. Practically, what will happen? So either will sometimes what will happen critically damped is will be used for some applications. For some applications, what will happen? We go for this underdamped oscillations. And some applications over damped. It all depends upon this one. So you see critically damped here what happen? The block is not permitted even to complete one oscillation. The block is even not permitted to complete one oscillation. The damping effect is very high. Now, what about under damp? Yes, the block will oscillate. Sine cos doesn't matter. Huh? So even I should start from here. It should be off like this. Just for a convenient, I just shown it. You'll get confused. Okay, no. What is under damp? It will oscillate. So maybe like what happened, the amplitude keeps on decreasing. The energy will be lost gradually. This is under damped. Over damped, what happened? It will take more time for the amplitude to decrease. One oscillation only, you can see that one. It is not permitted here to complete one oscillation here. Gradually, the amplitude will decrease here. So this is the type of thing will come. It all depends upon the value of B. Where do we use this critically damped? So if you look at the shock absorbers for bikes and cars, no, or vehicles, you can shock absorbers are very very important, no. So what is the purpose of that? As the vehicle moves away, so if any bump arrives here, suppose on a road, if any bumps arrives here or any pit, the way the inside the car, what will happen, which is here, Inside here what happened, so I'll just show spring so that it will be easy for you to understand. And the person is sitting here. Now once it overcomes the bump, after crossing that bump, what should be the state of person in the car? It should continuously oscillate, or I'll make little bit big. Some are telling sir what, not seeing anything. These are the, for our understanding purpose, I'm showing shock absorber and the person is here. Let's assume that. So these are the springs. What do you expect? As when the bump arrives here, the spring will get compressed and the person workman will not feel something, some sort of any jerk or something. So definitely workman, the spring will undergo compression and the person will feel comfortable. Once after crossing this, even after crossing this, if this is oscillating, the person workman will be oscillating. How you feel? So even the vehicle crossing the bump, if the still these springs are oscillating, the persons will not feel comfortable, no, but it should oscillate only for a while, so that what when you don't feel this particular bump effect on the body. Am I right, all of you? In the shock absorbers, two wheelers, or you can say four wheelers. So why do we have shock absorbers? What happen? We don't feel effect of this, or you can say some pit, uneven road. We should not feel effect. And this particular shock absorbers will protect this total vehicle. So what all that particular, you can say that damage, no, for that will occur for vehicle open, that can be overcome by this particular shock absorbers here. Now let's come for discussion. As the vehicle goes up, this will undergo deformation, and because of deformation, slightly we will also move this one. If they vibrate continuously, what happened to person? Even after crossing, this will be vibrating. This not good, no. That too, if for a driver, even after crossing bump, if you're vibrating, I think driving will not be safe. So what should happen? They should be critically damped here. So what shall I do now? Along with the springs, I'll fill up a liquid here, viscous liquid. So what that viscous liquid will do, will not permit the spring to oscillate like this under damped. Are you getting? So what they do? The springs, the liquid which is surrounding the springs, what happen? They will see that it be critically damped. The springs will undergo deformation, but immediately what happen? The deformation will be minimized. So like that, will feel comfortable. That's why if you look at the vehicle, as you move, if you cross over a bump, even after crossing bump, if you still vibrates, what is the problem? The liquid inside surrounding springs got damaged, or the springs might have got damaged. They'll ask you, suspension is a problem, or the shock absorbers is a problem. We have to replace. It will be of like this. Even this also not advisable. For shock absorbers, the condition should be like this. So vehicles, especially what happened, the front you can see, no, when you press your handle, you can feel yourself, no, the particular thing. So they should be of this kind, critically damped. The liquid surrounding the springs should be of this kind. It should be critically damped here. So if the liquid, what happen? If it loses its viscosity with the time, it will become under damped. So we have to replace that particular liquid. One example is what I'm giving. Where do we use and all? As very widely we are using in shock absorbers. For shock absorbers, what happen? The equation, the curve should be of this particular kind. Who will determine this? The value of P. Okay, I agree with this one. So this is the some basic ideas. Now, what are the types of questions? After what time the amplitude will become one-fourth of initial value? After what time the amplitude will become one-fourth of initial value? So what is the A of t? You can write it A naught by 4. So let's come to the equations. What is the type of numericals we can expect here? So this will be, after what time, find the time at which amplitude will be of the initial value. If they ask you like this, so what we should do, a of t, in place of a of t, a naught by 2. So a naught e to power of minus bt by 2n. So this will become 2 is equal to e to power of bt by 2n. Then taking log on both sides, log e, no, log of e to power of. So what is the time now? So time should be equal to 2m by b log 2. So the time at which the amplitude will become half of the initial value. Similarly, after what time the energy will become half of the initial value means what we should write here, E equal to E naught. Similarly, we'll calculate the time at which energy will become half of the initial value. So these are the types of numericals what were there that came in mains exam finally. So what students will do, sir, how this equation has come in mains exam, if you're thinking, I think there's a big headache, no? None of your business. You just ask find the amplitude after certain time in damped oscillation. B is the damping coefficient. Substitute here. You'll give value of B. You'll give the value of B. You'll give log 2 value. You'll give the mass. If I increase the mass of system, they'll take more time, no, for the amplitude. You see, you have everything in front of you now. If I increase the mass of the system, then it take more time for the amplitude to decrease half of the value. If I increase B, then it take less time. If I increase B, if I decrease B, it will take more time. So this is what. So we'll determine the shape of the curve, the value of B. Am I right? If B increases, then what will take less time for the amplitude to become half of the initial. If B decreases, it will take more time. So the value of B will determine the shape of the curves. I'm making things clear. Value of B and M, better say, mass and the damping effect, damping coefficient. Written. So the different curves are different curves. Shape of different curves depends on values of M and B. For different values of M and B, what happens? The system will behave in different way. Able to understand why the sir, why you are putting that one? If B is 0, then you get this one undamped. What do you mean by undamped? B is 0. So what is this? This will be B is I. For red color one, the value of B is very high. Getting the idea? So these are the meaning of this curse is what student has to understand here. Okay, fine. So this is, I think, just it's some theoretical information. You know to bother, and you have some equations. Based on the equations will come. Now, find the time at which energy will become half of the initial energy, half of the initial value. If they ask the question, what to do now? Let me introduce to the next one. Find the time at which will be of the initial value. So what is the expression for energy? We know E equal to E naught minus BT by M. Okay, yellow color shaded one. That only I brought it. After what time the energy will become half of the initial value. So this will become E naught by 2, E naught taking log on both sides. The time at which the energy will become offer. Again, it depends upon the value of M and B, how you want that energy to be varied. Okay, it's having wide applications at our level. I just gave one shock absorber is the best example what I'm giving. Okay, anybody have doubt till here? Okay, you can clarify it. We'll proceed to the next part. Now, sir, is it a sine cos who will determine? Again, that depends upon the initial from where you are going to count the time. Anything related to curve, if you want to ask, you can clarify it. Now, what do you mean by over damped, sir? Can you say anything about over damped, under damped? Okay, we'll write some conditions to over damped, under damped one. Over damped, let me write it. Undamped, undamped first, I'll write it. Undamped, the system oscillates at its natural frequency omega naught. Next one, over damped, the system returns to equilibrium without oscillating. This is very important. If I don't tell these things, no, from the graph, interpretation will be very difficult for you. In exam, these are the types of questions. What I'm writing, no, this is the way what they'll ask you. Critically damped, the system returns to equilibrium as quickly as possible without oscillating. Over damped, next what we have is over damped, critically damped, and under damped. Okay, next one. Under damped here. So the system oscillates at reduced frequency compared to undamped case with the amplitude gradually decreasing to the with amplitude. I think the bracket should be here. I'll put it at reduced frequency compared to undamped case. Okay, now tell me like how the shock absorbers should be. What do you expect? Should be under damped. It is under damped. What'll happen? Even after crossing the bump, what'll happen? You will be oscillating. So if the mechanical parts, car is made up of mechanical parts. If the mechanical parts, if they move more, unwanted moments are there, definitely what happen, the car will come under repair. The car may get damaged totally. So therefore, it should be critically damped here. Some need under damped. Some of the parts should be under damped. Some of the parts should be like over damped. Some should be undamped. So like this, what happen, it all depends upon the requirement. The technical requirement, what happen, I'll determine. So we determine what type of oscillation, the value of B and M. That is what, say mechanical engineering is not that easy. I'm telling you this one. So don't think that to be happy you're going to pick up engineering. I think from the beginning I'm telling this one. It's very complicated. It'll be very tough. As a teacher, I should tell you at this point only. To become happy, sir, I'm going to become engineer means then you are the biggest fool on the earth. To be unhappy, so that you'll be lot of pressure, lot of stress will be there for you. You'll be struggling day and night to find out the best efficient engine. That's what the engineering. Anything, mechanical engineer, software engineer, civil engineer, anything you want to become, you want to be unhappy, become engineer. You want to encounter troubles in your life, troubles in the sense not like financial, I'm talking the scientific challenges. If you want to accept all that one, okay, you become engineer. What you do, it become failure. Okay, like this, some setbacks, okay, what happened will be there for you. 5% success, 95% failure is what engineering. You'll never get success first stretch. You are going to do experiment many times. When you do 100 times, 5% will get success, 95% will be failure. This is what happens in engineering field. So engineering is not about perfection. Engineering is all about like how to reach perfection with patience. This is what a student should develop at very young age, the ability to learn, to fight with it. So what is the approach we have? The moment you see question, we want answer. Not possible. You will not become engineer. You'll become magician. Okay, getting the idea, no? So the value of B and M will define. So here for underdamped oscillation, the frequency will slightly decrease. What is the meaning of this? Sir, what is the equation? The equation already I have here. Because of B, what will happen? It will slightly decrease, no? So I'll write that particular formula, omega, or we'll paste it. Okay, I brought that particular thing. It decreases slightly. In fact, omega will be less than omega naught. Okay, there's a basic idea of this one. So what they do is they'll ask you, find the new frequency of oscillation of the system. If the value of B and M they give, the K and M will be available. What is the new frequency of oscillation? They'll ask you. So there's a new frequency of oscillation. Undamped this much, this will not be there. When underdamped only you have to use. So don't say for say like a critically damped, this is omega. In critically damped, what happens? The system will not oscillate. No, only in underdamped it will oscillate gradually. Okay, I think that's what I brought this equation. Many will ask me, sir, what is this one? You're not permitting it to oscillate. You're not permitting it to gradually come to equilibrium. This is what here oscillations. It will be like this. Means how the oscillations of that one spring block system. If you, sir, can you plot how the spring block system will vibrate for under dam? It'll be like this. The amplitude keeps on decreasing. Suppose initially this amplitude. So how the amplitude? It will be like initially like this. Okay, fine. It'll be like this initially. So look at the amplitude keeps on decreases. No. What about critically damped? Critically damped, finish over. What about overdamped? Overdamped, gradually it will come to equilibrium. Undamped, okay, this is undamped. Okay, now in your ohm, swing will be there, no? Swing, or you can say spring block system, anything, elastic band will be there. What type of motion you see? Underdamped, critically damped, or overdamped? Underdamped, no? You take spring block, I think some any elastic body there, tie one, some stone or some eraser or something. You displace and release, you see underdamped. Same thing, you go and immerse in some liquid, some dense liquid here, some sticky like oni or something. You see critically damped or over damped. In air, we see under damped. Fine. So any of the questions can be asked. Just be alert. Anybody have any doubt? You can say the mathematical ways of asking question is this much here. So what are the things? Amplitude, energy, or the new frequency? This frequency is only for underdamped. Anybody having doubt? You can just clarify because it's just only information. No. Sir, examples. Can you give examples of this one? Door. You take example of door. So let's take the few more examples so that you at least you can experiment this in. I'll give one more example. It depends on the value of b. How will b of means what shall I reply?
So like critically damped, you told B will be very high. So something
Some
like that,
value,
like range.
some value it is. Over
Okay.
them some value it will be that one. Return to it. This is example of dono under damped. And it's critically damped. A door. Best example, the door. I think this is a very you might have not noticed there's a problem. Sir, what is a door? How it translates? Please don't ask. You must know the physical world in which you are living. Don't tell me like, sir, what do you mean by door oscillation? All that one. You must know this one. You just give a push and release it. If the door returns back after oscillating one, two, three, say like a some after 5, 6, 10 oscillations, then it's under damped. If the door like a you just give a push and release it, if you just give a push and release it, if it oscillates, if it returns to this very slowly, means gradually it will come back or damped. If you give a push and release, immediately it will return back. It will be critically damped here. So who will determine this? From where it will come? So, okay, where is the viscous drag and all? The viscous drag, the air which is present, and also the friction at the inch, that will determine what type of motion it will come, that one. So what do you expect the door should be critically damped? If it returns back immediately, what happens? Especially glass doors, how they should be critically damped or over damped? How should be under damped? If you just open the door and release, if it oscillates like this, there's a big problem, no? Lot of sound will come. If the glass door, if it comes very quickly, the glass panel may get damaged, it may get broken. So therefore, what is the problem now? It should be over damped here. It should be designed in such a way. Okay, even for the doors of the car. Okay, we have so many examples are there around us. Only thing is we should open our eyes. But we don't open eyes. What happened? We just only open our textbooks and we want to learn science. You can't bring science. You can't learn science through books. That's what I'm saying. That one. Only say 5%. The remaining 95%, you should open eyes and look at world around you. Then only science will and science you can manage. But nowadays, what happens? Students are want to see science through the only book. That's the problem. Science cannot be learned only through the book. I'm not against the book, but trying to learn science only through book is a problem. As book is essential, but only through book is what? Now